Hi, everybody. This submodule, we're going to talk about climate versus weather. So this gets gummed up sometimes in the news. When we have a big storm hit or something like that, there's no doubt going to be people that point to climate change as the root cause for specific storm systems. Um, I, for one, do not subscribe to that. I think that that's really dangerous, simply because weather and climate, while related, are just two different entities. So, what is weather? Weather is what's happening now, what's happening over the next few days, maybe what's happening over the next week. Okay? So, how much rain am I going to get tomorrow? How much is it going to snow on Friday? Um, is this thunderstorm going to create a tornado? Those types of things. Am I going to get hail? Okay, so it's a shorter time period. Weather is for similar types of variables: precipitation, wind, temperature. All of that stuff is involved in weather and climate. It's just a time scale thing, and it's also a resolution thing. We can predict the weather on much higher resolution and much higher time scales than uh, we can climate. Climate is more broad. In fact, I'll switch over to the next slide. What is climate? Climate, in a nutshell, is the average weather over a particular period of time. Okay, so what? How much precipitation has fallen over the last 3 months? That's actually a short-term climate question. Okay, during the winter season, did we get more or less snow than we typically do on average? That is a climate question. Is it warmer this year than it has been over the last 50 years? That is a climate question, not a weather question. So, and and we'll also talk about how we predict climate with models and things like that, and how we predict the weather with models and things like that. And it'll also become kind of apparent how there's subtleties, but major subtleties that differentiate climate versus weather. Uh, this slide is actually uh, a plot of it's a climate plot. It is not weather. Okay, it's just temperature over different cities. It's comparing them uh, monthly average temperature over different cities over a typical average year. Okay, so that's a type of analysis that you would do in the climate world, um, and not necessarily the weather world. Okay, so just some subtleties there, but they're important. Climate also deals with oceans, ocean currents. Now, I'm not going to make you memorize a bunch of these ocean currents. We will probably talk about the Gulf Stream here uh, a little more often than we will some of these others. Also, although we'll also talk about El Nino, which is in this portion uh, of the Pacific Ocean. But I don't expect you to memorize all of these currents. Just know that they exist. So the atmosphere follows a lot of the laws of thermodynamics. So you can think of the atmosphere basically as a liquid. So we use a lot of those formulas to figure out how it circulates. We do the same thing with the ocean. In fact, the ocean is actually easier to predict than the atmosphere. It doesn't change as quickly over time because it's water as opposed to air, and it has a ceiling to it. The atmosphere, while it does end pretty high up there, it fluctuates as far as the height of the atmosphere goes, depending on the temperature. This is also kind of an interesting three-dimensional plot of something called the thermohaline circulation. Um, there's a lot of studies that go into looking at different circulations in different parts of the world. This one in particular um, is a circulation that's studied through looking at observations that sit on top of the ocean, and it's a pretty important, especially this portion for us. This circulation, it's important to figure out because depending on how the water is changing. So, for example, you have Greenland ice sheet here. Uh, if Greenland's melting a bunch of fresh water into the ocean, this circulation is going to change. The chemistry of the water will change. The pH of the water will change. We'll talk about that as well. So in this course, we're going to talk about the atmosphere, but we're also going to talk about the effects of climate change on the ocean and the effects of climate change on circulations of the ocean. The reason being is because there is a cause and effect and a nice correlation between the atmosphere, or connection instead of correlation, connection between how the atmosphere circulates and the ocean circulates. Another thing we're going to talk about, so I'm still staying at a pretty high level, and we'll dig into these a little bit more. Like I said, this module is just fundamentals. There's seasonally changing types of patterns that happen in the atmosphere. Specifically, we call these wind systems that change monsoons. So there's a really major monsoon that occurs over Asia that is seasonal. So when we start talking about seasonal things, we're talking about climate here. Okay, monsoons, they form similar to land and sea breeze, which we haven't really talked about, but in a nutshell, it's just a difference in pressure because of the difference in heating of the land or cooling of the land, and it switches the wind over a season. I'm guessing everybody saw Forrest Gump, where he talked about it starting to rain and it got upside down rain and all this stuff. That was actually this monsoon that we're talking about. So basically, in April, as the heat builds over Southeast Asia, wind comes on shore. It's very humid air that's coming on shore. There's also interesting elevation changes along this part of the world. So that also helps to create clouds and precipitation. Sorry about that. This is pretty dramatic. So this is a place called Cherrapunji, India. This is actually precipitation in inches. These are over months. So this is average annual rainfall for this particular spot, and look how dramatic it is. So this will put it into perspective. The average amount of rainfall or liquid precipitation we expect yearly in Denver is 16 inches. So in July alone, place Cherrapunji gets over 120 inches typically every year due to the monsoon. And then you also put all of these together, and you're talking about hundreds of inches of rain. So if they're not ready for it, there's some really poor areas of India and Bangladesh that get inundated every year with floods. So as the climate changes, these monsoons, there's likely going to be some kind of effect, potentially increases in the rainfall due to excessive heating over this area. Still yet to be determined, but definitely something that potentially could happen. The last thing I'm going to talk about is also a seasonal thing, but it's not seasonal per year, it's seasonal kind of on a decade scale. It'll happen every few years or so, which is El Nino. And I don't expect you to know how all of this occurs right now. We will talk about it a little bit as we go throughout the semester. It's very simple though. It's a seasonal change of the trade winds that go along the equator. So we're talking about the Pacific, equatorial Pacific here. Okay, so I do want you to know that. If I'm asking you on a quiz, what location on the globe are we interested in El Nino or La Nina? They're one and the same. They're just opposite. You can just say, the answer is going to be equatorial Pacific waters. Okay, I need you to know that right now, but we'll get into the El Nino effects a little bit later. So there are, I guess in a nutshell, there's seasonal climatic things that we've discovered. Whether or not we have control over them, yet to be discovered. But there's seasonal things like monsoons. There's actually a monsoon over that occurs over the southwestern United States that will affect Colorado. Um, if you think about Colorado, our major floods have happened late July, August, early September, specifically due to a similar type of change in wind that allows for a lot of Gulf of Mexico air to scoot over the top of us and create floods. Um, but climatically, uh, I just want to get the point across that it is a lot more complex than whether or not we push fossil fuels into the atmosphere. I know this is kind of a high level, but uh, it's ocean driven, it's land use driven. There's natural occurring things like El Nino and monsoons and things like that that have some predictability. Um, these are things that we will discuss throughout the semester, and hopefully it'll kind of open your eyes to the complexities that we're going to talk about as far as climate's concerned.